So let's assume that you have planned a business that you want to start, let's say even a restaurant business, right? You invested, let's say 1.5 crores and you have certain cash flows that you are getting, right? But you went to calculate using the rate function, but the problem with the rate function is that it does not assume that the cash flows will be uneven, right? But in the real world, in case of businesses, the cash flows can be negative. Sometimes the cash flows will be negative, sometimes it will be positive, sometimes you might reinvest it. So in all those scenarios, the function to use to calculate the returns is nothing but IRR. So in this video, what I'll do is I'll explain you from the basics on what is IRR. So this is the spreadsheet. It is downloadable, so you can just click on the link and download the sheet in order to calculate it with me. So when I say even cash flows, it means something like this. Let's say the investment is happening at year zero when you invested 100 crores, and then every year you're getting 50 crores. Not really very real world like, right? However, when you compare that with uneven cash flow, this is what a real world scenario would look. So let's come back to the same concept of present value, right? So present value formula states that PV is future value divided by 1 plus raised to n, right? So for now, let's take an discount rate out here, an assumption here, right? Let's say the cost of capital, right? I assume that you understand what is the cost of capital is, let's say 12%, right? So when I'm saying 12%, that means that this 100 crores that I'm investing, that I have got it at 12% interest rate, right? It might be interest rate, it might also be your own opportunity cost. So when you look at the overall cost of capital, let's say it is 12%. So obviously when you are talking about year zero, then the value of 100 is going to be 100 itself, right? Even if you discount it by 12%. But let's say I start discounting the year one cash flow onwards, so divided by 1 plus 12%, right? And raised to the number of periods, which is 1, right? Now you get some present value, right? So in this case, what you're doing is you're saying that, okay, 100 crores is what I invested and this is my present value. But this is actually not telling us how much return did we make. We are only saying that at 12%, the total investment is worth, in present value terms, we made 1.88 CR, let's say crores, right? So what the IRR concept is trying to do is, what if there is a certain discount rate, right? In this case, 12%, right? Or any other rate at which this, which is nothing but the net of the present value minus the initial investment, becomes zero. Okay, so the rate at which your NPV becomes zero can also be called as the average rate of compounding of your cash flows. Remember, we are saying it is the average rate of compounding. Okay, and that is what I meant, that each cash flow is getting reinvested, assumed to be reinvested at the IRR rate itself. But what is the IRR? So that is where we are using. Now, obviously, if you want to use a formula, you can directly use a function and get the IRR. But you will not really understand how this actually works. So what the method entails is to do a hit and trial method and try to find a rate at which this NPV is no more any number, but it approaches zero. So in that case, what we'll do is we'll use an NPV function. So NPV, we'll try out different rates. So that is the rate. And what we're going to do is we're going to take the cash flows from year one plus the initial investment. Okay. Now, since all of these values, cash flows, I want to be constant. So I'm just going to put a dollar sign here. Okay. And let's put this into the numbers values, right? And press Control C and paste it, right? So now you can see here, I have just made a chart of this same thing. You will see a very interesting thing that is happening is that at different rates, you've got different NPV. And we define the IRR stating the rate, right? The rate at which it equalizes the future cash flow to the present value, making that rate as the return that we are actually making. So if you see this chart, right, this is your present value, right? So present value at different rates. So these are the rates, right? And at somewhere between, if you can see here, between 12.5 to 13, right? 12.5 to 13 is which at the rate at which the NPV actually turns out zero, right? Now you can obviously extrapolate this and you can actually calculate using the graph also, but this is what the function actually does. So if I use the directly a function, it will calculate this as, if I just increase the decimal places, it will be 12.74. And if you want to try that out, what you can do is you can just write here 12.74, right? And that is the rate at which your NPV becomes zero. Somewhere around here is where your NPV is becoming zero, right? So you can see here 0.16, right? So that is nothing but an average rate of compounding. So the biggest assumption here in this IRR function is that it is assuming that as soon as you're getting 50 crores, it is getting reinvested at 12.74. Then you get 20 that also is getting reinvested at 12.74. That can be a very aggressive assumptions, because not in every business you are reinvesting your cash flows at the same business, because that opportunity has to be there. Let's say you are making a road project, right? So maybe in the road project you don't have the place to reinvest those 20 crores again, right? So that is a big assumption in the IRR function, but that's the whole theory behind the IRR formula itself. I hope you understood the video. Check back on the next video in which we will discuss on how to overcome the problems with the IRR function itself.